Welcome to Maths with Bob. Today we're looking at a determinant method to solve systems of linear equations. It's called Cramer's rule, and it's a very powerful rule to solve, for unknowns in systems of linear equations. Now, it is actually has a very important condition which you have to actually be careful of, and that's this one over here, that in fact the determinant of A is actually non-zero. Now, if it's equal to 0, it's called singular, and this won't work, so Cramer's rule won't work. And it only works on, for that matter, if you like, square matrices, and hence square determinants. Okay, well, determinants, you can only find a determinant for a square matrix anyway. But it basically works in n equations with n unknowns, if you like to put it like that. Okay, now the first thing is, let's have a quick look. What is the coefficient matrix to start with? I guess that's the first thing. So let's actually just grab the pen. So this is the coefficient matrix over here. Okay, it's you can see here. Okay, it's 3, 2, 1, minus 1. Now, where did that come from? Well, if you look over here, have a look at the coefficients of x and y. 3, 2, and 1, minus 1. Okay, so A, this is the, if you like, the matrix A is in fact basically formed from the coefficients. Okay, now, so this is called the coefficient matrix, and when we find, if you have a look in a minute, we're going to find the determinant of the coefficient matrix, and it's fairly easy to do. You might remember 3 times minus 1 minus 2 times 1, and giving us, okay, a negative 5 over here. Okay, so negative 5 is the determinant of the coefficient matrix, 3, 2, 1, minus 1. Okay, now we're going to have to start to modify this, if you like, coefficient matrix by putting the constants 8 and 1, the column matrix 8 and 1, in place of, okay, the coefficients for the particular variable like x, so 3, 1. You can see here x has got a coefficient of 3 and 1, so we'll put 8 and a 1 in here, 8 and a 1 there, and then we'll put an 8 and a 1 over here for the y, where in place of the y's coefficients 2 and minus 1. These are the modified, if you like, the matrices, and hence they'll form modified determinants. Okay, so this is part of Cramer's rule, which I'll quickly go over a bit more now. Okay, all right, so how do you do it? Well, the first thing you have to do is, obviously, as I said, find the determinant of the coefficient matrix, which we have already, minus 5. Okay, that's all right, minus 5. Let's actually just go to a highlighter. So we've already done minus 5. So we've already worked out that the determinant of the coefficient matrix A is minus 5. Now, we've got to do some modifications. Okay, so the modifications basically involve, you can see here, replacing the constant terms in particular positions in the original, if you like, the matrix, and then we find their determinant. So we form what's called A subscript x, which is, you'll see in the example coming up, is basically the determinant of the matrix where the constant terms are put in the x positions. Okay, and then if you look over here, you'll see that the determinant of AY, well, AY is the matrix where the, if you like, the constant terms are put in the y position, and then we find its determinant. You can see here 3, 1, 8, 1, and we find these particular values, and then we just divide them by the determinant of A, okay, which in this case is minus 5. We worked that out before. So this one is like minus 10 on minus 5, 2. And the y value you can see here is 3 minus 8. Okay, 3 times 1 minus 8 times 1. Okay, 3 minus 8, which is negative 5, and negative 5, which is 1. Okay, so if you like, the solution to this system of linear equations is over here, 2, 1, where x is 2 and y is 1, which would in fact would be a point of intersection of the two lines. Okay. Now, so this is how it's said formally, and you can see here we have ax equals b, A being the coefficient matrix, x being the unknowns column matrix, and b being the constants matrix, also a column. Okay, and you can see here basically what you do is you basically find the determinant of the coefficient matrix, dta, right? That's it. Or you can see they're all divided by dta. Then you have to do modifications individually for the particular unknown. Okay, so the particular unknown in this case is, okay, x1, or we did x before, so you have to modify the coefficient matrix and replace the constants in the x1 position. And the same for x2, you put it in the second column, and x3 the third column, and etc, etc. And I just put a bit note here that okay, A is a coefficient matrix, X is the variable or column matrix of the variables like X, Y, Z, or X1, X2, X3, etc. And B is the constant matrix, which also is a column. I've actually written it down here. You can see here it's just B1, B2, B3, B, etc, etc. Okay, so these are just the constants on the other side of the equal sign. Okay, so let's look at an example. Okay, so we're now going to look at an example. 3 equations in 3 unknowns. Okay, you can see here we have, let's go back to the magic pen. Okay, this is our system we're going to try and solve. Okay, so our system, you can see here, is x plus 2z equals 6, 3x minus 4y minus 6z equals minus 30, and x plus 2y minus 3z is minus 8. Now, one of the things you should realize is there's no y value in the first equation, so obviously its coefficient matrix is there's a 0 here, which is very handy actually, because in a 3 by 3 it's quite easy to expand if they have some zeros in the column or row. And as you probably remember, you can expand determinants via any column or any row, but at the moment these are just the matrices, and I'll go through and I show you, I form the particular modified matrices. Okay, you can see here the 6 minus 30 minus 8 is put in the x. Okay, the 6 minus 30 minus 8 is put in the y position, the y column, and you can see here finally the 6 minus 30 minus 8 is put in the z column. Okay, so the constants are going in the variables positions basically. And as you know, the x, y, and the z are formed basically by finding the determinant of the coefficient matrix and then the determinant of the modified coefficient matrices in turn, x, y, and z. Okay, so we need to work out these. Now, they take a bit of working out in a 3 by 3, and a 4 by 4 obviously more working out, and you can use some column and manipulation or row manipulations if you like to help you out in 4 by 4s. But luckily I did these ones without too much trouble. You can see here you might have to remember the alternating sign, so I go 1 cross. Okay, so I take this one here, 1, you might remember these, take the 1, cross out its row and its column. Okay, form the cofactor from the remainder parts here. Okay, you can see here. And then obviously to work out that's a 2 by 2 determinant, which is very easy. Minus 4 times minus 3, which is 12, and then minus 2, well, minus, it's a negative of negative 6 times 2, which I think works out to be 24. Yeah. Okay. So so basically then you go to 0, which obviously knocks that whole cofactor out, if you like. It's 0 times, if you like, 0. Let's have a quick look. It's going to be 0. Okay, it'll be 0. Oop. Okay, yeah, 0. But if you cut out its row and its column, okay, and you have a quick look at okay, what's left here. You have 3, 1, minus 6, 0. So it's 0 times that cofactor, which is still 0. 0 times anything, as you know, is 0. And then we go, remember the signs alternate, so it's plus, minus, plus. So it's 2. So it's going to be 2 now. Cross out its row and its column and its row, and then have a quick look at what's left here, forming the cofactor. As you can see here, it's going to be 3 times 2, which is 6. Minus is a plus. 6 and 4 is 10, but it's times by 2. 2 tens are 20. Now, obviously, the determinant of A is actually 44, and you can work this out with Geogebra as well if you wanted to. Okay, then you have to do the modifications. Okay, so the modifications are, now you can see here for the dt, the x. Okay, we're going to modify. We're putting the 6 minus 30 minus 8 in the x column. Then we're putting the 6 minus 30 minus 8 in the y column, and the 6 minus 30 minus 8 in the z column. And you can see here I've actually just worked these out. You can do row manipulations on some of these, but I didn't bother in the 3x3 because we've got a 0 here, which helps us and drops it out pretty easily for us. Okay, so hopefully you've seen the other videos and you know how to expand a 3x3. Now, if you haven't, perhaps you can go back and have a look at those videos, the previous ones on determinants. Now, okay, so here we have finally, we've got, if you like, remember we've had to find the determinant of the modified x, coefficient matrix, and we have to find its determinant. We find the determinant of the modified, if you like, the coefficient matrix A by putting the constants in the y position, and similarly for z. Okay, and obviously you can see here that when we put all the numbers together, we get x is minus 10 on 11, y is 18 on 11, and z is 38 on 11. Now I wrote down here, can you see the or spot the point of intersection? So I'll just actually show you what this looks like in Geogebra, and let's have a look. What happened? Did we do some rotation there? Okay, I just want to try and rotate this to show you. Okay, it's okay. So I don't know whether you can see the intersection of the three planes. This plane, that plane, and there's the blue plane here. Now we've also got the XY plane, which I'll just try and take out for you. Hold on a second. There we are. Bye for now, and thank you for watching.